Hi class, welcome to lecture again. So today in this video, we're going to talk about section 8.4 and we're going to talk about a very special probability models. You know, for the previous few sections and chapter 7, we were discussing, in the general, what is the probability, how to calculate the probability model. So in these sections here, we're going to talk about a very special probability model. We call this the binomial probability. Okay, so for the binomial probability, so they have a very special applications. And then instead of for us go to figure out the total number of sample size, events, then we also have a table constructed for the binomial probability. And even the TI calculator, will show us how to use the binomial probabilities here. So I'm going to show you how to do it. So the first thing here, we need to know what is the binomial probability. So the binomial probability is an experiment. And this experiment, okay, have the few conditions have to satisfy. The first one here is the same experiment is repeating a fixed number of the times. So that means you know how many times you are going to do this experiment. So I'm going to, give examples here to show you this is a binomial experiments here. So I'm going to say that I'm going to toss a coin 20 times. Right? So this is my experiment. I'm going to toss a coin 20 times. So I already know, so it's a fixed number. It's not that I'm continue doing it. I already decide I'm going to toss it 20 times. So this is what I call these n's here, right? So this is my n's here. This is condition number 1 here. And then the second one here satisfy for the binomial distribution is every time when you do an experiment, you only have 2 possible outcomes. That means it's either success, you can define it as a success, or fails here, okay? So like in this example, I said, I toss a coin 20 times. So I only get 2 outcomes. Correct? So my outcomes here is head and the tail. Okay, so then one of them you can define it as a success, and one of them you can define it as a fail. Depends on what you are interested in, right? So here I can say, oh, I can define that my tail is a success. It doesn't matter. So if one is a success, then the other is a fail here, right? So it depends on how do you define and what you are interested in, you wanted to do. That's what is a condition number 2. So you only have 2 outcomes here. Okay, so number 3 is here. They said the repeat trials are independent. So the probability remains the same from trial to trial. What that means here? So probability here, since we defined the tails, right? So we defined to get a tail is a success. So the probability of the success, I use the P. So I know the P's here to get a tail is 1/2, so it's 50%. So the first time I toss a coin, then I got the first time I got a 50% of a chance to get a success. Then the second time I toss a coin again, I still got a 50% of success, right? So the trial to trial, that's why my probability going to what? Remain the same from the trial to trials here. So like the P is 0.5 from the trial to trials. Then the last thing here is we said, hey, the binomial random variable is defined as the number of success. It's defined how many things you are looking for, right? So for example, I can have a different random variables. So for example, say I want to find what is the probability I'm getting like 4 tails, right? That means that my random variable will be equal to 0. It's the number of success. Or you can say, how about I will have the 0 tails. That means that after this 20 trial, I'm sorry, here's 4. You know, after this 20 trials, here you got a 0 tail. Then your random variable value is equal to 0, right? So all I will say at least 12 tails. I want to see if I do this, what is the probability I get at least 12 tails. So then your x here at least will be greater than or equal to 12, right? That's how do we say it is like, that's what we say, is the binomial distributions here. And then I'm giving you is a binomial experiment. So let's take a look at other examples here. And so I said, let's say here, I toss a die 10 times. Well, so in here, the first condition satisfies, right? So you toss a die 10 times, so A is equal to 10. Well, then the next ones here, we say we have 2 outcomes. You say, oh, no, die has 6, the 6 faces, so I don't have 2 outcomes. Well, depends on what you want to look for, right? So if you say, I'm care about the faces is bigger than 4. So if this is what is your concern, yes, you do have 2 outcomes, right? So your faces is bigger than 4, so that means 5 and 6 will be on this outcome. And this is 1, 2, 3, 4. So you still have 2 outcomes. Now, if you are care about the faces were bigger than 4, then you can define that here, this is a success. Right? So whenever you get a 5 or 6 is a success. Then whenever you get a less than equal to 4, you say this is a failure here, right? So this ones here depends on what your interest, what is your success you defined, right? So you still can have 2 outcomes. Then the next thing here, they will tell you here is like a P. So the P is here is the probability get a 5 or 6. So I know the P's here is 2 over 6. So this is 1/3, right? So I know when the first time I toss a die, what is the chance I'm going to get a number bigger than 4? 1/3. The second time, still is 1/3, right? The fourth time, still 1/3. So I know this experiment, it is a binomial experiment. Then you can define your random variables, right? So you will say you said more than 6 times. So for example, if you say you more than 6 times, you will get a number bigger than 4. So that means out of the 10 tosses here, you're interested in the more than 6 times, right? So what is your random variables here? Your random variable is x is greater than what? Greater than 6, right? That's what we mean is the binomial distributions here. And so it depends on how do you define your random variables, and then the number of the success here is depends on what you're interested in, okay? So let's take a look here. Let me give you another example that I'm going to write down. So like in here, for examples here, I have 25 questions. I have 25 multiple choice. Okay. questions. And each questions has 5 possible answers, but only one is correct. Okay, so here, so let's say here, if you did not study, and just randomly guess the answer, what is the chance you will get 18 questions correctly? Okay, let's see. What is, so I'm doing these ones here. So the first ones here, let's see here. This one satisfy what we call this, the binomials here. First, the n is fixed, right? So I know the n is 25 questions here, right? So you have 25 multiple choice questions. So n is fixed. I'm doing the experiment. So every question is one trial. Every question is one trial. And I also have 2 outcomes. Right, so when you do each questions, you either get a correct answer or you get a wrong answer. Right, so you either get a correct or you get a problem wrong. Okay, so now what is the probability you will get correct? Since you're not studying, so you just randomly guess. So one question out of 5 questions are correct. So the chance you randomly guess will just be 1/5. So it's only going to be 20% chance you will get that correct answers here, right? And now, so you can say the correct I'm defined as a success. And the wrong answers here, I'm defined as a fails here. And now you say, hey, what is the chance that I'm going to get 18 questions correctly? So what's that mean? That means your random variable, right? So your random variable here, x is equal to what? X equal to 18. So you know this is a binomial experiment, and you need to find the probability x equal to 18. That means you need to use the binomial distribution to find it. So now we know how to identify an experiment is a binomial or not. Like I said, binomial is a very special distribution, right? So after you know that, after you know that, then how to find the probability is easy because we're going to we have the calculator. I'm going to show you how to do that. So, but first, let me write it out, the formula for you. So the binomial probabilities here. Okay, so sorry, a while ago got a phone call coming. Sorry for that. Okay, so for the binomial probabilities here. Okay. So this is how we write it. So we want to say the probability, the x is equal to my, whatever my random variable x is here. So that means the x success, right? So that means the probability to get x success in the n trials here, right? Okay, so the formulas here is this. This is n factorial, x factorial, n minus x factorial, and then this is the px And then this is 1 minus p n minus x. If you still remember in the sections like 8.2, what is this expression? This expression really is the combinations, right? So you can write this one as c the nx and the px, 1 minus p, the n minus x here. So this is our formula. You can use this, do a hand calculation, or you can use the TI-84. And I'm going to show you how to use the TI-84 to do the calculation. So you don't need to plug the numbers into the formula and get it, okay? So let's take a look at some examples. It's pretty easy here. Okay, so let's take a look at the first examples here. This is, oops, I don't want the red color. Okay. Okay, so the example ones here. Okay, so this example is suppose a family has 5 children. Suppose the probability of having a girl is 1/2. Find the probability. Okay, so let's take a look. Right, so let's find the probability. Okay, so here, the first one's here. Let's find the probability. Exactly 2 girls. Exactly 2 girls. And 3 boys. And let's find the next one. The probability is no girl. Then let's see here, the D's here. C's here is no more than 2 girls. Okay, so in here, let's start, right? So in here we said, okay, the family has 5 children, right? Family has 5 children, so the experiment is set, n is equal to 5. And then for each experiment, you have 2 outcomes. So you have a girl or boy. Then you can define that doesn't matter. So you say girl is a success because I'm trying to here, and the boy is a failure. So here it doesn't really mean failure. It's just like you can define that these 2 outcomes here. Then they say the probability of a girl is 1/2. That means P is 1/2. That means the first girl will be the 1/2, second one is 1/2, right? So we'll assume the chance for the girl is 1/2. Okay, so now I'm finding the probabilities here, right? So random variable X is here, I can define is the number of girls, right? Okay, so in here, because I have 5 children here, so when they say I'm getting exactly 2 girls and 3 boys, that means I'm really looking for the X equal to what? I'm going to the X equal to 2, right? Because if I get 2 girls, exactly 2 girls, I automatically assume I get 3 boys there, right? Okay, so let's take a look. How do I get this probability by using the TI-84? Okay, so I'm going to switch to the TI-84 calculator, and then you guys watching carefully what the key do I hit, right? Okay, so here, let's clear this out. So in order to do that, so the first things you need to do, you do a second, then do a distribution. Then you go down, okay? You go down to the here, did you see a binomial PDF? I'm going to tell you the differences between the binomial PDF and the binomial CDF, right? Okay, so in here we choose the binomial PDF. So you put an enter. So the number of the trial is 5. Probability is 0.5. What is your random variable value? Number of success is 2. Then you go down and you hit enter, then you hit enter. It's 3125. Okay, so it's 3125. So I'm go back to my whiteboard. So here is 3125. So this is a pointer 3125 here, right? So be careful here. If you remember what I did a while ago, I used the function called the binomial PDF. Okay, so this is the TI-84 functions I used, right? So the PDF means here, right? So whenever I did for the PDF, you know, whenever you use the PDF, is under the situation, you try to find the probability X is equal to some values here. So the PDF is only applied when you try to find the probabilities equal to. Okay, so let's take a look at the second ones here, right? So let's say no girls, right? So that means you are doing probability X equal to what? 0, correct? Okay, let's switch back to the TI-84 calculator. Okay, so now we do the same thing. Second, let's try one more time, distributed. Right now you go down to the binomial, because it's equal, right? So I use a PDF. Okay, so trials is 5, probability is 0.5. Now, because it's 0 girls, so I put the zeros here, right? Then I said here, so it's a 0.03125. Okay, so it's a 0.03125. So I stopped sharing. I'm going back to my whiteboard. So this probability here is 0.03125. Okay, so I'm still using what? I'm still using binomial PDF, right? I'm still using this key. The reason I use this key because this is equals, right? So we said you use the PDF, this is equals here. Okay, so the next ones here we say no more than 2, right? So no more than 2, what does that mean? That means you are looking for probability X is less than equal to 2, right? That means you could have 0 girl, 1 girl, or 2 girls, right? So it's no more than 2. So it's a probability X less than equal to 2. You can write it this way. You can say, hey, this one is X equal to 0 plus X equal to 1 plus X equal to 2. Then you can use the binomial PDF 3 times, then add them together. But that's a lot of work. So that's why they have another functions here in the layer. We call this is the binomial CDF. Okay, so the binomial CDF, what is the CDF mean? That means cumulative. That means if your probability model is X is less than or equal to some number, you use the CDF. Okay, so now let's go back to our TI calculator. So this is less than equal to 2. Then let me see. Okay, so I'm going to the TI calculator. Okay, so now clear the screen. So you say the second distributed, right? Then you go down, all the way down here. So did you see here binomial CDF? Yeah, so you say enter. So your trial still is 5. Your probability still is 0.5. What is your x value? X value is 2 here, right? Because it's less than or equal to 2. Then in here, you will get this is a 0.5 here. Okay, so let me stop sharing here. Then go back to my whiteboard. So that means this, the probabilities here. This is the 0.5. Okay, so that's what is the differences between the PDF and CDFs here. All right, and so if you know how to use the TI calculator, this section is a super easy section. You can just plug the number and get it in there, right? Okay, so now let's take a look at another example. So now I think you'll feel pretty comfortable about this type of the binomial distributions here. Okay, so let's see here. So this is example number 2. Okay, so the example number 2 is telling you the probability that certain machines turn out a defective item is 0.05. Now I want to find the probability that in a run of 75 items. Okay. Okay, so now let's take a look. How do we do this, right? Okay, so now the part A here is, let's say, what is the probability exactly 5 defective items? Okay, and B, no defective item. Okay, C, at least 1 defective. All right, so now let's take a look here, right? So in here, let's see how do we do it. So we said, the probability of machines to turn out defect is 0.05, and find the probability in a run of the 75 items. So my number of the trials is fixed, right? So N is what? N is 75. I want to check 75 items. Then for each item, I have 2 outcomes, right? So I have is defective. Then I have one other one is a good item, right? So now, because I'm looking for the defective, so I would say, okay, whenever I get a defective, I get a success. Whenever I get a good, I get a failures. Yeah, it's kind of like sounds weird, but because we said it doesn't matter which one you define success, fail. It depends on what your interest, right? And then now the probability also tell you the chance to get defective is 0.05. Okay, so now we want to find exactly the 5 defectives, right? So we can put these ones here. This is x equal to 5. And now the no defectives, right? So it's x equal to 0. Okay, so now let's switch back to our calculator and see what we try one more times, right? Okay, now I'm going to share the calculators here. Okay, so remembers, right? So, okay, second distributive, then you go down here, you go to, because I'm looking for exactly 5, right? Exactly 5, that means I use a PDF, right? Correct? So how many trials I have? 75. What is the P I have? The rate of success, find the defect, is defective, is 0.05, right? What is my X value? Exactly 5 defect, so it's 5. So it's 0.14877. Okay, since we are here, let's do the no defective, see what happens here. You write down, go ahead and write down this number. So let's do no defectives, right? No defective, so in here still is a PDF, right? So still 75, but my X value is what? It's zeros, right? Okay, so no defectives here is 0.02134. Okay, so you guys, write down these two numbers. So let me switch back to my whiteboard here. Okay, so still remember what we did here? So we got a 0.1488, right? And the no defective is, I think we got is 0.0213, if I remember correctly. And do you remember what the function we use? We use the binomial PDF, right? So we know the binomial PDF is because they are what we are looking for, the equal signs, right? So if it's equal sign, so we use the PDF. Okay, so now we said at least, right? At least one defect. So like we talk so many times, when we talk about at least, right? So how do you write it? At least, that means it's more than one or more. So it's x greater than equal to 1. So for these problems here, x greater than equal to 1 could be 1, 2, 3, 4, 5, all the way to what? To a 75 here, right? So that's very difficult to do. So that's what is we did before. Anybody should remember, right? So I'm asking you questions. I hope that when you watch this video, you will answer me. So what do we do? I hope that inside your mind, or you can speak out loud if you are by yourself, so no one thinking you are weird. You can say, hey, it's 1 minus the probability x equal to what? Zeros, right? Okay, now we already got x equal to 0 from the previous. So what is this answer? So it's 1 minus 0.0213. And this will give us the 0.9787, right? Okay, I do want to, so this one's here, we use a binomial CDF, right? I do want to show you one kind of the things here. So let me add one things here. Okay, so if I have, how I'm going to use, right? So if I have a binomial experiment, right, with n is equal to, let's say 20, and the p is equal to, let's say 0.37. Okay, so we already know, we know how to use the calculator. So we said that if it said x equal to 13, right? So for this ones here, you can use what? Binomial what? PDF, right? Because it's equal. All right, so we also learn if I say probability x equal to 11, what we can use? We said because it's less than equal to, we can use what? We can use a binomial CDF, right? You just input that, directly input. It's very easy. The only things here are a little bit different. You need to think about it. So if I say that I want to find the probability x is greater than equal to, let's say 8, how do I do it? Right, so this is a greater than, right? So the way you want to use this, okay, so I'm drawing a picture for you. So here, this is from 0, 1, 2, 3, 4, 5, 6, I shouldn't choose that many, 8, 9, 10, right? 11, to 20s, right? Okay, so I'm looking for is greater than equal to 8, right? So I'm looking for the probability of success is greater than or equal to 8 is from 8 all the way to here, right? But my I only have the CDF is less than. I don't have the CDF is greater than, right? So I need to think about a way to do it. So because I'm looking for is from the 8 to 20, and the only thing I know here, from the 7 and the less, what is this one here? This is my CDF. It's less than or equal to 7, right? So the way I can write this one here is will be 1 minus probability x equal to less than equal to 7. You cannot minus 8. You cannot say x is less than equal to 8 because you don't want to minus 8 out. So the green one is the probability you want, right? So it's minus less than 7. Then now this one's here, you can directly input it to the binomial CDF, right? Okay, so the one more example, you will see the differences here. If I said here, depends on what your problem asks you, right? So if your problem asks you is greater than 8, okay, so now how do I think about greater than 8? So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, to 20, right? So now take a look, it's greater than 8. That means 8 is included or not included? No, 8 is not included, right? So really I'm looking for is this is greater than equal to 9, right? Because this one here does not have an equal sign. So it's greater than equal to 9 because A is not included. So in order to use our calculator, what I need to do, I need to minus out all the way to here. Right, so in here, for this one here, this one you can say, this you can minus out, x is less than equal to 8, right? And the less than equal to 8, you can input this one into the binomial CDF. Remember the binomial CDF, right? So when you take a look at the CDF, it's always have equal sign. So for the greater than, you need to draw a line and see what you are looking for. Now, which part you need to minus out, so you'll be able to use the binomial CDF to get you the probability. That's just the kind of extra notes. I think in the My Math Lab, they have a couple problems they want you to find the greater than, and then you might need to, write it out and see what happens here. Okay, so this is the section 8.4 is about the binomial distributions. And I think in general, it's not too bad. It's, make sure you know how to use the TI-84 calculator to get the value. Of course, if you don't have a TI-84 calculator, in fact, the binomial distribution is a very, very popular distribution. So you can just go to the internet and Google, you can say binomial distribution calculator. So you will see, so they will have a calculator for you. But of course, you need to know the terminologies, right? Like number of trial, number of success, CDF and the PDF concept. So you will be able to use those calculators as well. I don't care you use a TI-84 or you use some internet free calculator. You can find some free calculator in the internet very easily. Okay. Okay, good job. And so make sure to review the video, make sure you understand the topics we are talking about. And of course, at the end, don't forget to do your classwork. All right. So it's nice to talk to you again. So I will talk to you next time. Have a good day. Okay. Bye.